down and make up new substances. So it depends on three stage. Like there is a three-stage process through which the catabolism goes through. So that stage, like we have got three stages to go through the process of catabolism. The number one stage, which is I'll say that conversion of complex molecule into their building blocks. Like we eat some food, you eat a meat, your biscuit, whatever you want, that's a complex molecule. And what we're gonna do first, we're gonna conversion of complex molecule into their building blocks, So what happens? For example, you are taking a polysaccharide. Like if you have a polysaccharide, so what happens? The polysaccharides are broken down to monosaccharides, lipids to free fatty acids, and glycerol proteins, and the proteins are going to break it down to the amino acids. So what we're going to do, we're going to convert the complex molecule of the food we eat in the form. We're taking protein, we're taking carbohydrate, whatever we're taking, we have to bring them to the normal, or you can say the building blocks. Number 2 point we have got is the formation of simple intermediate. So what I mean by the simple intermediate, like the intermediate which is in between. So acetylcholine is the best example of as an intermediate. So I'll write it, the formation of simple intermediate. All right, so we have an example, we got acetyl CoA. So what happens? The building blocks produced in stage 1, like we got the building blocks in stage 1, we got what we got the amino acids, we got the fatty acid, glycerols, and the monosaccharides. So those building blocks are degraded, we break them more, and to simple intermediates such as this acetyl CoA. So this is a simpler one, that was the more complex one. So the building block, this one is much simpler. So I'll just do it like this. You see this way. I'll just do it this way. What I'm gonna do is I'm gonna make a shape. All right. So what we're gonna do, this is food we ate. The carbohydrate, this C is a carbohydrate converted into the monosaccharide, and in case of protein, it's converted into the amino acids. In case of lipid, it's going to convert into the fatty acid plus glycerol. All right. So these all going to end up into the more simpler one, that is acetyl CoA. All right, this first reaction, the first stage was conversion of complex into the simpler one, and the second was the formation of we're gonna more simplify it, and we're gonna make the building blocks into acetyl CoA. So what happens? The building blocks produced in stage 1 are degraded to simple intermediates such as acetyl CoA. So these intermediates are actually not readily identifiable as carbohydrate, lipids, proteins, because you cannot say acetyl CoA is a lipid, protein, wherever, but these convert into the acetyl CoA through a different stage processes. So this one is a simpler one, and this is finally used for other reactions. So the final stage is that we're gonna oxidize the acetyl CoA is going to be oxidized. So number 3 stage will be the oxidation, final oxidation of acetyl CoA. All right, so we're gonna oxidize the acetyl CoA. What we're gonna oxidize it? Because we need energy. So the energy is released in the Krebs cycle. So what happens? That this is the third stage. We're gonna need energy. So this acetyl CoA is going through the Krebs cycle, and we're gonna get the energy. So energy could be in different forms. For example, we get the energy in the form of NADH or the FADH2. So NADH is actually equal to 3 ATP molecules, and FADH is kind of equal to 1.5 ATP molecules. So this is kind of balancing how much, comparing with the ATP, the NADH. All right, so these were the stages of catabolism, and now let's talk about a little bit about the anabolism. So anabolism is very simple. We talked about it a little bit. So anabolism means synthesizing the large molecules of a variety of complex molecules, by collecting the building blocks, all that is going all the catabolism, all the products coming from catabolism are going to the going through the process of anabolism. So we want to make complex molecules. So by what we do, we use a few main materials like pyruvate, acetyl CoA intermediates in the TCA cycle to make new products. So these products are actually, they depend on energy. So energy we got from catabolism can also be used in the anabolism, because we got energy in the form of NADH, FADH2. So this is this will be providing energy in the product of anabolism, because anabolism is endogenic reaction. It goes through endogenic reaction, which means it needs energy. But catabolism does not need energy. It's very spontaneous. It releases energy. Now let's talk about the types of metabolic reactions. So there are actually 4 main types of metabolic reactions. How many? 4 main types of metabolic reaction. So first one would be the redox reaction. Redox reaction. Redox reaction means reduction and oxidation going together. The second one would be the group transfer, the main group that is available in any molecule. Group transfer. And the third one would be the rearrangement and isomerization of any molecule. So we would say that rearrangement and isomerization. The last one but not the least one is number 4, which is making and breaking the carbon-carbon bonds. So you can say make and break carbon-carbon bonds. Alright, so this is just an introduction regarding the metabolism. I hope I cleared the concept. So one thing more to add up, these are the there are like let me explain it this way. There are actually there are many enzymes, like there are around 2,000 enzymes, and each enzyme is specific for specific reactions. So that should be clear. Like all reactions do not go through the same enzyme. There are different enzymes, so there are specific enzymes for different reactions. And that's it regarding the introduction of metabolism. All right, so see you in next video. Keep visiting Tigers Schooling.